Hello everyone. My name is Ignacio Reyes. I'm a machine learning engineer at ALeRCE, and I will show you a little bit about the training sets, the machine learning models that we're using, and some validation that we have performed over the models. So the first thing that we have to do, of course, is installing ALeRCE client to get some data from ALeRCE and importing some typical Python packages. Um, and well, the first model that I want to talk about is called, we call it the Stamp Classifier. It's basically a convolutional neural network that takes image stamps from the alerts from CTF and classifies them into 5 classes, which are active galactic nuclei, supernovae, variable stars, asteroids, and bows. Of course, it's hard or it's not possible to classify them perfectly with just a stamp. In fact, we're using just the first stamp, but you can still do a pretty good job. For example, if you notice that there's a host galaxy, or there's a very, very bright star with a mask here, basically the model can still learn and give you useful information. And it have proven very useful for detecting early supernovae. And you can see here the confusion matrix for the test set. And there's some confusion in some classes, but in general, it does a pretty good job. And this work is under review, but you can look at the paper, the preprint in the archive here. And well, the first thing that I want to show you about this model is how to get some classifications. Basically, using the ALeRCE client, you can query objects and ask for classifications done by the Stamp Classifier for a given class with a minimum probability threshold. And in this case, we are doing this for each one of the 5 classes, and we are getting here some examples of the objects. So after that, we can, for a given object, in this case, this is a very pretty supernovae that we find out. You can ask for the light curve here with query detections. And here we will retrieve a pandas data frame with, in this case, 58 detections. After that, you can get the stamps from the client. In this case, for example, with the CTF object ID, and optionally with the cand ID from a specific observation. And then you can retrieve these stamps and plot them, for example, with this auxiliary function. And here we can see the template image with a host galaxy, the science image with the supernovae, and the difference image. The second model that we have running in real time is the Lycra Classifier, which is basically a model that looks at the light curves from the alerts and tries to perform a classification using this taxonomy. Currently, we have about 15 classes with transient objects, stochastic objects, and some variable objects. And it's a model based on feature extraction. We have a bunch of features. Francisco showed a little bit about that in the previous talk. And after performing some feature extraction, we use a model which is based on a bunch of random forests. And then we have a classification. This model was published recently in the Astronomical Journal in a paper led by Paula Sanchez. And this is the confusion matrix for the test set. And as you can see, the matrix is quite good, and the confusion tends to be inside the macro groups. In this case, for example, among the different kinds of supernovae, because they can be hard to distinguish just using the alerts without extra information. Here we have the confusion between the stochastic objects, and here the confusion between the variable stars. And this is work in progress. We're trying to add as many classes as possible. As this paper is already published, we have available the training set, which is which was created using crossmatch with other catalogs. And you can download the training set here from Zenodo or using this command in the notebook. And here we can look at the training set that we used. So basically, this is the frequency for different kinds of classes. There are some very common objects like Euclidean binaries or some variable stars. And there are some objects where we have very few samples. For example, this case, for superluminous supernovae, we have about 20 objects. So it's a classification problem with a high unbalance. And you can also look here at the original sources where we get the labels from crossmatch. For example, here Catalina, Gaia, Meliquas, Assassin, etc. You can get the predictions. In this case, we're using we're directly querying the database here, downloading the credentials, accessing to the database, and here you can query the different taxonomies that we have in ALeRCE. For example, here you can see that there's a model which is the Lycra Classifier, and those are the different classes, and there's a version associated with that. We also have the Stamp Classifier here. There are, in this case, two versions of the model with the respective classes, and those are, in this case, for the Lycra Classifier, we have some sub-models. You can read a little bit more in the paper, but basically all or every prediction is linked with a taxonomy. So you can know basically which are the other classes that sum up to one, and also keep track of the versions. And in this case, we are going to retrieve some of the probabilities from the probability table. And as you can see, we have in these cases OIDs, object IDs, we have the models, the versions, and the different classes. And this is a very important thing. There's a column. It can be kind of confusing, so I will try to explain it, which we call ranking. For example, in this case, this row, this object is called CTF18, blah, 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 has a ranking of 14 and a class of ALeRCE. So basically, it means that ALeRCE for that object is a very unlikely class with a very low probability, and in fact, it's almost the less likely class. And for example, here ranking 1 means this is the most likely class. So basically, this object here was most commonly classified with a probability of 32% to be a delta Scuti. So basically, if you retrieve all the rows for a given OID, you will get all the different vector probabilities, or all different probabilities from the vector with different numbers for the ranking.
2 minutes, Ignacio.
Okay, thank you. So here we are retrieving a bunch of probabilities for the lead classifier, and we can do a histogram of the classification. In this case, not the training set, but the classifications. And this is very nice because it works as a sanity check to see if the model is predicting or finding the amount of sources that we expect. For example, we expect a few transient objects, few superluminous supernovae, and a lot of variable stars. So that's good. And well, you can see it later if you're interested in this with a little bit more detail. But we also perform some other sanity checks. For example, we check the length of the associated Lycras for the Stamp Classifier, and also spatial distributions for the objects. For example, I will try to show you an image. We look at in the space where located the predictions for different classes for the Stamp Classifier and for the Lycra Classifier. And these have been for us very useful to know or to be more sure that our model is performing well, not just looking at the confusion matrix, but also looking some other data and contrasting that with some other astronomical knowledge. So you can keep looking at the more details in the notebook if you want to, and ask any questions. So thank you very much.
Perfect, Ignacio, right in time. So I don't see questions in Slack for Ignacio, but please feel free to leave them there and tag him if you have questions for him.